This is a story about silk and milk. The silk is from golden orb weave spiders.
Here you go, pumpkin.
They're incredibly inquisitive. They're a lot of fun.
The milk from specially bred goats. Good luck trying to connect those dots. So what's the thread?
There's a lot of interest in spider silk fibers because they're stronger than almost any other man-made fiber, and they also are elastic.
Because it's stronger ounce for ounce than other materials, there are many possible medical uses, from artificial ligaments to sutures for surgery.
So the question is, how do you produce large amounts of the material?
Spider farms just don't work. They tend to kill each other. So molecular biologist Randy Lewis figured out how to put the spider's silk-making genes into goats.
What we did was put that gene into some goats in a situation where they would only make the protein in their milk. And when the goats have kids, and then they start lactating, collect the milk, and we can purify that protein in much, much higher quantities.
With help from the National Science Foundation, Lewis studies spider silk at the University of Wyoming. And so far, Lewis says he's seen no differences in the health or appearance of the transgenic goats.
Good girl. Oh, come on. Come on. I know. You don't want to go down.
Feeding and milking goats and wrangling spiders are sometimes part of the job.
So we collect the milk out here, and then we take it back to the lab for processing.
The silk we're particularly curious about is the dragline. That's the outside of the web.
Chemical engineer Heather Rothfuss separates the silk protein from the milk. No arachnophobia for her. In fact, she's actually warmed up to working with spiders.
I'm on the roll now, so it's collecting okay.
Just 4 drops of protein processed from the milk can be spun into 4 yards of silk.
It's eye surgery, plastic surgery, nerve surgery. They understand that you can't just farm spiders, so you got to come up with another way to make the material.
Rapidly evaporating liquid helium cools until at 2 degrees above absolute zero, a dramatic transformation takes place.
Suddenly, you see that the bubbling stops and that the surface of the liquid helium is completely still. The temperature is actually being lowered even further now, but nothing particularly is happening. Well, this is really one of the great phenomena in 20th century physics.
The liquid helium had turned into a superfluid which displays some really odd properties.
Here I have a beaker with an unglazed ceramic bottom of ultrafine porosity.
Ordinarily, this container with tiny pores can hold liquid helium. But the moment the helium turns superfluid, it leaks through.
We call this kind of flow a superflow.
Superfluid helium can do things we might have believed impossible. It appears to defy gravity. A thin film can climb walls and escape its container. This is because a superfluid has 0 viscosity. It can even produce a frictionless fountain, one that never stops flowing. Superfluidity and superconductivity were baffling concepts for scientists. New radical theories were needed to explain them.
Normally, this tiny animal waddles around on its 4 pairs of plump little legs, sucking the juices out of mosses and lichens. But when the going gets tough, how can the cute and squishy water bear be tougher than a grizzly bear? The water bear is the most extreme survivor on the planet because when conditions get tough, this animal effectively curls up and dies. It loses 99% of the water in its body and enters a state of suspended animation. Let's say a water bear starts getting too cold. It'll shrink down, retract all its legs, and shut down all systems until conditions improve. Once they're in this state, they're practically indestructible. Imagine if you were as tough as a water bear. If things started getting too cold, all you have to do is curl up and lose virtually all the water in your body. You'd enter a state of suspended animation. Freezing solid would be no problem to a human water bear. Water bears can survive temperatures as low as -328 degrees Fahrenheit. Extreme heat would be no trouble either. Water bears have survived a scorching 303 degrees. Imagine if a human was exposed to radioactive material. You could be 150 miles downwind from a nuclear blast and still get a lethal dose of fallout. That's about 500 rontgens, the units used to measure radiation. The indestructible water bear has been shown to survive 1,000 times that amount. And life in the desert would be no trouble for a water bear. With nothing to drink, most humans would last less than 2 days. But even camels are no match for one incredible water bear. A long time ago, a water bear was trapped in a museum specimen of dried moss. It came back to life when scientists added water to the moss 120 years later. The water bear's toughness is literally out of this world because it could even survive the vacuum of space. It seems you can never judge an animal by its soft and squishy looks.
Strange phenomenon